Welcome, student, to this application of rate of change and derivative. So in example number 9, it says that if the demand for a product is given by this formula. So the price demand, it depends on the number of quantity, it's given by this formula. Remember, once we talk about the demand, we know that the curve will just decrease as the quantity increase. If more people wants the product, the price will start to get lower and lower. If more quantity are available, the price will just go down, and this is the demand law. Now, the question is, we need to find the average rate of change of a demand B increases from 1 to 25. So what we have here is, what we would expect here is the following. If the quantity is 1 and it jumped to 25, we know that the price here will be higher than the price here, and maybe the function will go like something like this. Now we need to find the average rate of change, so we need to find the slope of this secant line. And we have a formula to find the average rate of change. So here, average rate of change, it will be just P of 25 minus P of 1 divided by 25 minus 1, which is the slope, y2 minus 1, y1 over x2 minus x1. Now, all what we need to do is we plug in 25 in the formula, minus 1, minus, we plug in 1 into the formula. Of course, this is, you can just do it in your calculator. The final answer, if you do it correctly, you will get negative 800 divided by 24, which is negative 33.333. Of course, this will be the average rate of change. Usually, its average rate of change, it will be, I will explain it later in part D, but the unit will be dollar per quantity. So for each increase in quantity of 1 more product available, the price will drop negative $33.33. I'll explain it later, but this is the formula. Question B is the same as question 1. We need to find the average rate of change. Which means it is P100 minus P25 divided by 100 minus 25. Now, if you do it with your calculator, you should get negative 100 divided by 75, which is equal to negative 1.3333. Same thing for the next one. Average rate of change equal to B100 minus P1. Of course, how do we find B1? We substitute Q equal to 1 in the formula. We substitute Q equal 100 in the formula. We got the answer. You can just plug everything in your calculator at once. This will be negative 900 over 99, which will be negative 9.09. And those are the average rate of change. Now, part D, where we need to explain a little bit more, which interrupt the results from parts 1, 2, and 3. Let me start with part 3. Now, if we just take part 3, that means for every extra quantity, or if every increase in the quantity by 1, the price will drop by 9.09. Similarly here, for each increase in the product, the price will get negative 1.33, and we can see here in every increase in the quantity between 1 and 25, the price will start to drop negative 33.3. Now, how do we combine those three together, it looks like the highest drop happens from 1 to 25. So at the beginning, once we increase the product from 1, 2, 3, 4 up to 25, the price will drop dramatically. Same thing, if we just jump from 1 to 100, we continue doing it, the price will drop, drop, drop. If we take the average total drop will be negative $9. However, if you see here, after 25, it does not matter anymore. Even if you increase the quantity, the price will start as average to drop less and less. So we know that at the beginning, from 1 to 25, there we will have a huge drop in the quantity. So if we want to control the market, if we want to keep our profit, we should manage at the beginning from 1 to 25. We don't increase the availability of the product that much in the market. Now, if it happens and, for example, we supply the market with too many products, after 25, does not matter. We can just go ahead and supply more and more because the drop in the price will be just as an average smaller and smaller. And that's what's the interpretation for those results. Next, we go to example number 9, and this is something very important. Whenever we saw marginal revenue, marginal profit, marginal cost, this means we need to find what? We need to find derivative. So in this example number 9, we'll start finding the derivative. If you can read the question, we have a total revenue function of a mixer in dollars. So I have the formula for the revenue, and X is the quantity sold. The first question is, what is the marginal revenue function? Remember, whenever I see marginal revenue function, it's like I see what is the derivative directly. It's like, boom, this is the same as this. How do we find the derivative? Well, R prime. Now, so far, the only way we know how to find derivative is we use the definition. Later, we will see how we find derivative using the formula. So by definition, h goes to 0, r of x plus h minus r of x divided by h. Next, h goes to 0. The next step, as we usual, we write just the function with x untouched. And here I need to write it again, but instead of every occurrence of x, I will write x plus h. X plus h divided by h. We need to deal with this. How we deal with this? We go to them term by term and try to simplify them. So this will be, I'll go one by one. First of all, 18 will be distributed because it's outside. So I will get 18x, 18h minus 0.005. Have a bracket. How do we expand x plus h square? It will be the first square, second square, and 2 times first times second. So this will be straightforward, x squared 2xh plus h squared. Next, the minus will go inside. So it will be just negative 18x, negative 0.005 x squared divided by h. The next step, this number has to go inside everywhere. So just write it down there and continue with the same thing. So this will be limit as h goes to 0. X minus 18h minus 0.005x squared minus 2 times 0.05, it will be 0.01 xh minus 0.005 h squared, and finally minus 18x plus 0.005 x squared. Now the cancellation are clear, x squared, 18x and 18x. So whatever will survive is 18h, 0.01hx, and 0.005 h squared divided by h. Next step, take h as common factor and cancel it. So h, we have 18h, oh, we already take the h as common, minus 0.01x minus 0.0505 h divided by h. Cancel, cancel. The next step, substitute h equal to 0. If we substitute h equal to 0, this will disappear. So the final answer is 18.01x. And that's the marginal revenue. So the marginal revenue equal r prime of x equal 18 minus 0.01x. And that's how we find the marginal revenue. We almost solved a similar question in the previous part of when we have the x squared. And that's the marginal revenue. So here, marginal revenue, remember, it's only finding the derivative. Next step, it's ask us what is the marginal revenue when 300 units are sold. So that means we need to find the derivative at 300. Now we remember the derivative, it is this one. Now instead of x, you write 300. And just plug everything in the calculator, the answer will be 15. What does it mean, 15? First of all, what is the unit? 15 what? Is it $15? No, it's actually will be $15 per unit. Now, what does it mean? It means, and let me write it down in green, for any increase in the number of units What do we mean increase in the number of units? For example, if we increase it from 300 to 301, the revenue will increase by $15. So if you just add one more unit, whatever your revenue will have an extra 15 more. So it gives you an indicator. Is it worth it to produce more units than 300? Remember, if I just add one unit extra, the only revenue I will get is extra $15. Now, same question, we will do it for 2000. So everything should be the same. I even can copy and paste this one. And then I'll change it accordingly. Let's see. Okay, now suppose we reach 2000 units. What will happen if we increase it a bit more? So we want to know what happened after we produce 2000 units. Suppose we produce it to 2001. What will happen? Well, actually, we need to find the answer here so that we know how much my revenue will also increase. This will be -2. So actually what will happen, and let me cross this one so that you remember when you study at home, my revenue will not increase, it will be decrease by $2. The negative sign for the decrease. So when you reach 2,000 units and then you start adding one more, your revenue will decrease. So it is a very bad strategy to reach 2,000 and then you increase it. That's the marginal revenue. And you can see that in business application, the derivative is a very powerful decision-making tool for the manager to set. If he knows the derivative, he knows how to model his revenue, he knows where not to increase the product in the market. Usually we always feel that the revenue should always be, whenever we sell more, we get more. But sometimes demand, supply, cost, many other things, many factors can play